I'm Anil Kumar. Welcome to my series on review of quadratic functions. This is for my grade 10 students who have taken up MPM2D. Take it as an exam review. We have 10 questions to discuss. Here is the 10th question. Solve these and then look into my solution. Let us take them one by one. Question number 1. We have two parts here, part A and B. Simplify square root of 300 plus 2 times square root of 27 minus 3 times square root of 48. That's part 1. Square root of 300 plus 2 times square root of 27 minus 3 times square root of 48. Let's do this first and then we'll take up the next one. So the idea here is to write the number within the square root as product of 2 where one of them is a square number. So 300 could be written as 3 times 100, correct? 100 is 10 times 10. We could write 27 as 9 times 3. And how about 48? 48 could be written as 16 times something, right? 16 times 3. Now as you see here, square root of 100 is 10. So I could write this as 10 square root 3. Square root of 9 is 3. So we could write this as 2 times 3 outside, the square root sign. 3 remains inside. Minus 3 times square root of, well, square root of 16 is 4. So we can write 4 outside. And 3 remains inside. Okay, so we'll write 4 outside. Now let's simplify this. 2 times 3 is 6. So we could write this as 10 square root 3 plus 6 square root 3 minus 4 times 3, 12 square root 3. Now square root 3 is common, so you can add all these. So we get 10 plus 6, 16, and 16 plus 12, 28. So we get 28 square root 3 as our answer. So I hope that is absolutely clear. Now let's do the next one, which is square root of 5 minus 2 square root 3 times square root of 5 plus 2 square root 3. Now by now you know what is the product of sum and difference, right? Let me remind you what is a minus b times a plus b. As you know, this is a squared minus b squared. So we could directly apply this formula. If you want, you can multiply them, apply distributive property, and then get to the result. Since this is final exam review, I'll straight away apply the formula and write this as a square minus b square. That is to say, square root 5 square minus 2 square root 3 whole square, right? So that is what I will do. You could do one by one, right? 2 extra steps will be required. Now what is square of this? It is 5. And here we get 4 times 3, right? Square of 2 is 4. You have to square 2 also. 4 times 3 is 12. So we get 5 minus 12. And 5 minus 12 is negative 7. So that is how you are going to simplify these radicals. Now it's very important to understand how to do it, since in quadratic equations we use quadratic formula which has a radical. Let's look into the next question. Question number 3. Here is 2 factor. Again we have 2 examples, 2 factor. We will do them one by one. So the first one here is 2x cubed minus 8x squared minus 42x. The second one is difference of squares, 3a plus 1 whole square minus a minus 1 whole square. Now first you could factor 2 as a group factoring, right? So I will write this expression as equal to 2 times, you could also factor x. So let me write 2x straight away, right? So 2x. So we get x squared minus 4x minus 21, right? So we factored both x and 2. Now what you get is a quadratic expression where the coefficient of x is 1. So we are now looking for two numbers whose product is minus 21. So we are looking for two numbers, let's say p and q, whose product is minus 21 and whose sum is minus 4. So what are these numbers? Well, 7 times 3 can work for us, right? So 7 times 3 can work. So one is 7, the other times 3. Since we need negative 4, 7 has to be negative. When you multiply, you do get negative 21. So we could write now the expression as 2x x minus 7 times x plus 3. So that is the factored form of the given expression. Let's do the second one. 3a plus 1 whole square minus a minus 1 whole square. Now here we'll directly apply the formula. A square minus b square equals to a plus b times a minus b. So a in this case is what? Well, a in this case is 3a plus 1, right? So this whole thing will treat this as one factor. And this is the other one, right? Let's call this as b and this is a. So what I'm trying to say here is that this could be treated as difference of squares, and you could factor this as, let me write square brackets, a plus b, which is 3a plus 1 plus a minus 1. So that is my first factor, a plus b. Now we are going to multiply this by a minus b, that is 3a plus 1 minus of this, that means both signs will change. So I'll write like this. Is that clear? Let us now simplify this. 3a plus a is 4a and 1 minus 1 is 0. So we get 4a, and for the second factor we get 3a minus a as 2a, and plus 1 gives me plus 2. We can actually factor out 2 also. So we get 4a times 2, a plus 1, multiplying we get 8a times a plus 1 as the final result. So that becomes the factored form of the given expression. Now let's take the next one, which is question number 4 for us. Solve the equation 3x squared minus 13x minus 10 equals to 0. Now this type of equation can be solved by a couple of methods which you have learned. One of them is the method of factoring. So you could factor and get the result. You could use quadratic equation also. So those are two methods which could be adopted. Now let me first try to factor. If not, then we will use quadratic equation, right? To factor, we are looking for, let me rewrite the question here. We have 3x squared minus 13x minus 10 equals to 0. We are looking for two numbers whose product should be, let's say p times q should be minus 30. Product of 3 and minus 10, and their sum should be equal to minus 13. So what are those two numbers? Well, you could try 15 and 2, right? So if I use 15 and 2, let us say, then we do get 30 as the product, right? One of them has to be negative. The bigger number is negative, since we need sum to be negative. So that should help. So now what we will do is basically split the center term into two terms and rewrite the equation as 3x squared minus 15x plus 2x minus 10 equals to 0. We can actually now group the terms in twos, right? So we could group them as these two terms, right? So if you group them, you can take 3x common from the first group. You get x minus 5, and you could factor 2 from the second group, getting x minus 5 equals to 0. Now x minus 5 is a common factor, so we get 3x plus 2 as the other factor. When we say solve equation, that means find value of x. That satisfies the equation. Perfect. Now in our case, we have now two particular solutions. One could be x minus 5 equals to 0. The other one could be 3x plus 2 equals to 0. So we have x minus 5 equals to 0. That gives you the value of x as 5. The other one is 3x plus 2 equals to 0. That can be solved as 3x equals to minus 2 or x equals to minus 2 by 3. Minus 2 by 3, right? So that is how you get your solution. Once we have the solution, we can definitely write down the answer, and the answer for us is x equals to 5 or x equals to minus 2 over 3. Okay, so that is how it can be done. Now let's do the next question. Question number 5. Solve the equation x minus 5 equals to square root of x plus 1. Let's rewrite the equation. X minus 5 equals to square root of x plus 1. Now to solve such equations, we should square both sides. So the first step is square both sides. Remember, whenever you square both sides, you actually create some errors at times. Since square of a negative number becomes positive, so you could expect some erroneous roots. So you have to check your solution, right? So remember to check your solution. This is very important. Okay, so let us square both sides. What I'm trying to say is we'll just square both sides like this. So when you square, what do you get? On the left side, we'll use the formula a minus b whole square. We get x squared minus 2ab, which is 10x, plus 5 square, which is 25. And on the right side, we get x plus 1, right? So here, we use the formula a minus b whole square is equal to a square minus 2ab plus b square. Perfect. Let's bring all the terms to one side. So we get x squared minus 10x plus 25 minus x minus 1 equals to 0. That gives you x squared minus 11x, and 25 minus 1 is plus 24 equals to 0. Now at this stage you could factor. So 12 and 1 can work, right? So we are looking for product of two numbers p and q equals to 24 and sum of these two numbers as minus 11. So the two numbers could be 12 and 2, right? So, well, 12 and 2 will give us 24 but not 11. 8 and 3 can give you the right solution, right? So both negative. So negative 8 and negative 3, when you multiply, will give you 24 positive, right? So it could be factored as minus 8, x minus 8 times x minus 3 equals to 0. Now these factors provide you with two different solutions. For x minus 8 to be 0, we get x equals to 8, and for x minus 3 to be 0, we get solution x equals to 3. So these are two possible solutions. Now the idea is to check your result. That is extremely important, right? So let us check the results and see if they are right or not. Remember also, when you are saying x plus 1 within the square root, you know one thing, that x has to be greater than or equal to minus 1. So they are within your domain. Still, you have to check the result. Perfect. So let us write down x as 1, x as 3 and 8, and then check. So if I write 8, so basically we're trying to figure out if left side is equal to right side or not. So we'll try for x equals to 8 first. So if I write x equals to 8 here, I get 8 minus 5, and on this side I get square root of 8 plus 1. Now 8 minus 5 is 3. Square root of 8 plus 1 is 9, which is 3, and we know both are equal, so it works. So this is correct. So this solution will work. Let's do the next one, which is 3. So if I do 3 minus 5, and if I do square root of 3 plus 1, square root of 3 plus 1 gives us 2. But 3 minus 5 is minus 2. Minus 2 is not equal to 2. So this root is erroneous, not a solution. Is that clear? All right. Now this happened mainly because we squared, so we squared negative to make it positive. Perfect. So we get our answer. The only answer here is x is equals to 8, and that is how this question should be answered. Is that clear? Now let's take up the next question, which is question number 6 for us. You need to graph y equals to 2x squared plus 16x plus 31. Now, to graph quadratic equation, it is a good idea to do completing squares. So we'll complete squares. Once you get the vertex form, then it becomes easier to graph, right? We'll use steps. I'll show you how. So we are given the function y equals to 2x squared plus 16x plus 31. To complete squares, we'll take 2 common, coefficient of x squared, the leading coefficient. You get x squared plus 8x. Keep this term separate, plus 31. Now, we have to add and subtract half of 8, right? So we have x squared plus 8x. Half of 8 is 4. So we'll add and subtract 4 squared within the brackets. Now you will notice that the first 3 terms form a perfect square. So we could write this as equal to 2 times x plus 4 whole square minus 4 square is minus 16 plus 31. Now let's open the bracket. So we get 2 times x plus 4 whole square minus 32 plus 31. We can combine the last 2 terms, which are constants. So we get 2 times x plus 4 whole square minus 1. Now that is the vertex form from where we can actually read the vertex and then sketch the graph. So what we have here is vertex of the parabola is at minus 4, minus 1. It opens up, right? And what are the steps? Steps are multiples of 1, 3, 5, 7, and so on. And we have to multiply by a, the stretching factor a, which is 2 in this case, right? So we do have a vertex at minus 4, minus 1. So let me sketch here. Let me make a rough sketch of a coordinate plane, right? Let's say this is our coordinate plane. Okay. So in this coordinate plane, minus 4 means we'll go to this side, minus 4, minus 1, and the steps are 2, 6, 10, 14, and so on, correct? So those are the steps involved in this particular case. So let's say this is like 1, 2, 3, 4. So this is minus 4 for us. 5, 6, 7, 8. Let's say this is minus 8. Similarly on the right side, 1, 2, 3. And then minus 1, minus 2, minus 3. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the first point is the vertex itself, which is at -4, -1. So 1, 2, 3, 4, and -1 means you come downwards. So that is your point, -4, -1. Now the steps are, when you multiply by 2, you get a step of 2. It opens up. So when you move this side, you have to move 2 units up. So that is the second step. Do you see that? Third step will be 6 up. So the next time when you move either side 1 unit, you have to move up by 6. So this is 1, 2, 3, 4, 5, 6, 7. That is up by 6, correct? So when you reach 7, so that is your next step. Joining these points, you get your graph. Is that clear? Joining these points, you get your graph with vertex at -4, right? So this becomes your graph of parabola. You can join these points kind of like this and get your parabola. In the test, normally you'll get a graph paper, so you can do a much better job, right? So this is x and this is y for us, right? So this is -1 and that is 1, right? And this is 7 for us. So I hope that makes sense. Let's move on and take question number 7 now. Determine x-intercept of y equals to -0.5 x plus 4 whole square plus 2. Okay, so let's rewrite the equation. Y equals to -0.5, let me write as half x plus 4 whole square plus 2. We need to find x-intercept. Now what does that mean? At x-intercept, y equals to 0. So we'll evaluate x, we'll find x for y equals to 0. So let me substitute 0 for y. So we get -half x plus 4 whole square plus 2. Now to solve, let's take this 2 on the left side. So we get -2 equals to -half x plus 4 whole square. Let's multiply by 2 both sides, rather minus, so it becomes positive 4 equals to x plus 4 whole square. And now we can square root. Whenever you square root, you have to do plus and minus, and you get x plus 4 on the right side. Square root of plus and minus 4 is plus and minus 2. So plus and minus 2 is x plus 4. So that becomes a part solution. Now we can actually find the value of x. Let me write it on the right side. So what we have here is that x plus 4, x plus 4 equals to plus minus 2. Taking 4 to the right side, we get x equals to -4 plus minus 2. So we have two solutions, and we can write this as x equals to -4 plus 2 or -4 minus 2. So which is -2 or -6. So that becomes the two x-intercepts for the given relation. Now as a part of exercise practice, what you can do is you can graph, right? So we have the x-intercepts. Let me write down the answer. The x-intercepts are -2, 0 and -6, 0. But I'll give you an additional question to work with, and that is graph the function or relation, or graph the equation. Okay. So when I say equation, you should definitely mark these points, the x-intercepts. Okay. Let's move on. Question number 8 for us is express -3 x plus 3 whole square plus 75 as factored form. Now there are two alternatives which are commonly used. One is expand then simplify. Now here we have a very special case, so I will use a different method to factor and then write it in factor form. So I'm going to use our learnings of factoring. Let's see how. Now this is a very effective technique, and that is why I'm actually concentrating or rather focusing on this method. So the equation given to us is y equals to minus 3 within brackets x plus 3 whole square plus 75. So what you can do is you can take minus 3 common. So if I take minus 3 common, so I get x plus 3 whole square minus 75 divided by minus 3 gives you 25. Now you know 25 is 5 squares. Think like this. What we have here is actually difference of squares. Do you see that? What we have is the difference of square, and that could be factored, correct? So you could write this as a plus b times a minus b. So we could write this as x minus 3 plus 5 times x minus 3 minus 5. Do you see that? And we have factored it. So let's open the bracket and simplify these terms. We get minus 3 times minus 3 plus 5 is plus 2. So we get x plus 2 here. And minus 3 minus 5 is minus 8. Do you see that? So that is the factored form of our equation. So what we utilized here is the knowledge that a square minus b square is indeed equal to a plus b times a minus b. So that is a very, very effective way of doing it. Let's move. Now let us take up question number 9. Parabola has a y-intercept of minus 4 and pass through the points minus 2, 8 and 1, minus 1. Determine the vertex of the parabola. So let us begin with the standard equation of parabola, which is y equals to ax square plus bx plus c. Now we need to find the values of a, b and c using 3 given points. Points are the y-intercept, which is minus 4. In this equation, c actually is the y-intercept, right? If you substitute 0 minus 4, which is the y-intercept, what do you get? Let's do it. Minus 4 for y and 0 for x. So we get 0 plus c, and that gives you that c equals to minus 4. So the value of c, which is the y-intercept, is given to us as minus 4. With that, we can write our equation as y equals to ax square plus bx minus 4. Let me call this as our equation number 1. Now we are going to use the other 2 points to find a and b. The second point is minus 2, 8. So let me substitute minus 2, 8 now in our equation, which is y equals to ax square plus bx minus 4, which we are calling as equation 1. So 8 is the value of y, minus 2 for x, so you get a times minus 2 square plus b times minus 2 minus 4. Bring minus 4 to the left side, so we get 8 plus 4 equals to 4a minus 2b. So it is 12 equals to 4a minus 2b. You can divide by 2 and get 6 equals to 2a minus b as your equation. So we'll call this particular equation as our equation number 2. So we already have equation number 1 is right there. And we are calling this as our equation number 2, which we got by substituting the point minus 1, minus 2, 8, right? So that's equation number 2. To solve for a and b, we actually need to use the third point also, which I'll do on the right side of this page. Now we'll substitute 1 minus 1 in equation 1. So y value is minus 1, so let me write minus 1 here. X value is 1, so we get a plus b minus 4. Let's rearrange. We get minus 1 plus 4 equals to a plus b, or 3 as equal to a plus b. So this becomes our third equation. So with 3 points, we get 3 equations. These 3 equations can help us solve the question. If you do 2 plus 3, you can eliminate b, right? So now we will do equation 2 plus equation 3. 6 plus 3 is 9 equals to 2a plus 3a is 3a, and b minus b is 0. So that gives you the value of a as equals to 9 over 3, or 3, right? So we get the value of a as 3. So out of the 3 unknowns, we know 2 of them now. C is minus 4, a is 3. To get the value of b, we can use equation number 3, substitute a, and get the value of b. So if I substitute a as 3 in equation 3, I get 3 equals to 3 plus b. Now that is possible if b is equals to 0. Perfect. So we get the value of b as 0. Knowing a, b, and c, we can definitely write down our equation, which is y equals to a is 3, x squared, and c is minus 4. So y equals to 3x squared minus 4. The question here is to find vertex of the parabola, correct? So the question here is to find the vertex of the parabola. So vertex is at x equals to 0 and y equals to minus 4. So we can write down the vertex as at 0 minus 4. So it becomes our answer. So I hope it is absolutely clear. Go through this video once again. Try to understand how we got the equation from 3 different points. Now, let us take up question number 10. The value of c will make the expression x squared minus 8x plus c a perfect square trinomial. So let us understand, what do we mean by a perfect square trinomial? Let's remind you of a plus b whole square. A plus b whole square is a square plus 2ab plus b square. Now this is a trinomial which can be written as a perfect square. So that kind of an expression is called perfect square trinomial. So I hope it's clear, right? So this kind of a trinomial is written as perfect square. Now we could have plus or minus. So we could have either one of this. In our given expression, we have x squared minus 8x plus c. Now here, in perfect square trinomial, what you notice that this center term should be written as 2 times something. So let me write this as 2 times 4. So I could write this trinomial as x squared minus 2 times 4 times x plus c. So we get 2 times 4. Now if you compare with the expression, then what is the relation between b and the constant? So this b becomes b squared as a constant. So what we will do here is we'll square 4, right? So we'll square 4 and write it down there. So what you get effectively is that c should be 4 squared. So what we get here is x squared minus 2 times 4x plus 16, and therefore clearly we get c as equals to 16. You get an idea, right? So that is how we can make a trinomial a perfect square. Perfect. Now you will test for yourself that this can be written as x minus 4 whole square. Correct? We actually missed question number 2. So now I'm going to take question number 2 as the last question of this exam review. Question number 2 is, for what value of k does the equation y equals to 5x squared plus 6x plus k have each number of roots. 2 real roots, 1 real root, and no real root. Well, as you know, condition for 2 real root is b square minus 4ac should be positive, greater than 0. Condition for 1 real root is b square minus 4ac should be equal to 0. No real root is b square minus 4ac should be less than 0. Then we get only imaginary roots, right? This is when we take up an equation which is y equals to ax squared plus bx plus c. Now in our case, we are given the equation y equals to 5x squared plus 6x plus k, right? So if you compare, a is 5 for us, b is 6, and c is the constant k. So let's figure out what is b square minus 4ac, right? Equate it to 0, and then we'll get the other values also. So in our case, b is 6, so we write this 6 square minus 4 times a is 5 and c is constant k. Let's equate this to 0 and find the condition for 1 real root. So we get 36. Bringing this to the right side, we get 36 is equal to 20k, right? Or k equals to 36 divided by 20, which is 1.8. So for k equals to 1.8, we have 1 real root, correct? For no real root, this number should be negative. When will it be negative? It is going to be negative if k is greater than 1.8, then this will be more negative, right? So for no real root, k has to be greater than 1.8, and for positive, 6 square should be greater, right? So k has to be less than 1.8 to make 6 square or 36 as greater than the negative term. So in this case, k has to be less than 1.8 for 2 real roots. Perfect. So that is how we get our solution to question number 2. That brings us to the end of this exam review. I hope you understand and appreciate how we solve these 10 questions. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Also watch my videos on trigonometric relations and the other analytical geometry. I hope you find them all useful and interesting. Thanks for watching, and all the best.